All right.
All right. So, thank you everyone for joining. This is Kartik. He is a very distinguished alum from 2013 batch. He is researching on verified programming language for quantum computing. Uh,
ഇല്ല ഇല്ല ഇല്ല
as,
ഇല്ല ഇതിപ്പോ തീർക്ക ഞാൻ വെറുതെ.
could you mute yourself, Nigel? Thank you. So he's been very much interested in like answering a question regarding force and his research topic. Uh, so let me introduce Kartik. Hi.
Hi, thank you for seeing. Thank you for inviting me here, and I'm glad to talk with you all. You're, I think, doing a lot of effort trying to get students engaged in open source, and it's really nice to see that.
Thank you. So we have collected a few questions from the Google form that was circulated. So first we'll get the questions that have been open source.
Atul, can you please mute your mic?
So perhaps you can announce it once, because I think Zoom may be new to a lot of people. We should keep it muted for now.
Is there an option to mute everyone when they join?
There is a button called Mute All. You may be able to see it as a co-host.
Ah, yeah, there is. Okay.
All right.
Right. So let's start with the questions.
Sure.
Okay. First question: how much has FOSS helped in your career? Could you talk about how much have you contributed to FOSS, or has it helped you in getting your admissions or your job?
Yeah, it's a sort of a complicated question. You may not see direct impact by just contributing or trying to contribute, but I think overall it has helped me a lot in my professional career. I got involved in FOSS-related activities, actually a little bit even before starting college, back in Ghaziabad, where I grew up. It's a city in Uttar Pradesh, close to Delhi. They already had a Linux users group where, which I discovered maybe a year before starting college. And at the time I was learning to use Linux on my own, so I went to one or two of their meetups. So it was nice to see a community of users who were already, out there helping each other learn and giving workshops and stuff. So you can continuously learn more skills that are useful later in your professional life. So at NIT Calicut, pretty early, I think within the first month, I figured out there was a FOSS community called FOSSCell, as you all know. And I got involved with that. And one of the main things that helped me right away was just learning about and knowing a lot of seniors within like my first month of college. And I think that helped me grow a lot. It helped me learn more about the college life that I was going to experience. And also I sort of found a community within, pretty early, apart from just the first years that I was interacting with in the, I believe it's called A hostel, right? Where first years are put in. So I think that itself was a great experience. Then as I got more involved, there were more events being organized. Like there is FOSS Meet that we do, which helped me connect with the rest of the community across Kerala, or sometimes even across the country, because we would invite guests from outside the state as well, Bangalore. So that kind of networking helped a lot later. And in terms of contributions, I would say during college, I was frustrated and that at least in my first 2 years when I was heavily involved with FOSSCell, I was not actually contributing in terms of code directly. So it was more from the perspective of organizing things, promoting or advocating about the philosophy of FOSS and stuff. So that sort of frustrated me. But also at the time, things like GitHub were not around or not very common. They were just coming up. So it was easier. It was not as easy to get into open source, I think. So that's one perspective. But over time, as things, got better, I think my first contribution that I remember happened around when I was in 2014, when I was already out of college and was working full time. So one of the themes I saw was that, contributing to open source primarily happens when you have a itch to scratch of your own. That is, you want to do something and you find a project that is close to that, or you find a problem in a software you're using. So that's a place where one can easily find themselves motivated to actually go and fix it. So it was kind of like that. So some of you may have heard of the Hugo project. It's used for static website development.
Yeah.
So I had just picked up the language Go around that time, and or I was picking it up, and I was also trying to redesign my website. So I heard about this project Hugo that was it was probably a year old by the time. And they had, I thought I'll use it because I like the general idea of how web pages were completely static. You didn't need a VPS to host your website and all. So when I did that, I realized their RSS support was pretty messed up. And RSS is the way you generate feed for your website, which can be then read by things like Feedly or FeedReader, or basically RSS readers that help you track new content on websites. So that's where I found my itch to scratch, and I went and fixed the issues they had in their RSS code. RSS and atom feed generation code. So that involved looking at the actual specification of these protocols and figuring out why Hugo's current version was not compliant, like, getting into all the messy details and fixing that, doing your pull requests and stuff. So yeah, I mean, it took me a lot of time, I guess, back then, but it was a journey, and I realized that's how most people get into it. And over time, you learn, like talking about the benefits you get in your professional career, you learn how to interact with other people who are working on technical projects. You meet people that, it helps you grow in your network. Sometimes those networks lead to, collaborations or opportunities like a job offer or internship. And maybe we'll talk about more about this later. But in academia, where now I am at, a lot of projects are done open source online on GitHub. And if you are already familiar with that ecosystem, it helps you a lot just navigating everything. And not just academia, I mean, a lot of industry work is also happening that way these days, as you probably are all aware.
Yeah.
So did I miss anything from your question? I went on a
No.
pretty big tangent there.
That's so. You said that most of the FOSS software produced by people scratching their own itch.
Mm-hmm.
Okay. Do you think that is it possible to develop a commercial FOSS product?
Yeah, I mean, I didn't mean most of it, but yeah, when you're starting out, that's kind of, at least for me, it was, why would you even want to contribute to open source, right? That happened when I wanted to fix something. So in that sense, yeah, it was more from the perspective of motivation. But I think these days, a lot of open source software is developed because many companies are commercially supporting it by paying their developers to work on open source software full time or even part time. I mean, the sort of arrangements vary, but lot of open source developers are paid developers, right? Coming to your main question about whether companies can be built around open source software, it's a pretty challenging problem, and a lot of studies have been done on success and failures of many companies that came around trying to build their sort of payment models around open source. So it's challenging. It's not impossible. The reason being, I mean, let's think of companies like Red Hat that's given as one of the main examples that has been successful, at least in the last 30 years or so, or beginning of those 30 years, which they're primarily an open source company, but selling open source software doesn't work very well because most people, when they hear open source, they think that it's free, and they can also just download that software on their own and install it and use it. So a lot of companies have to take this support model where, they will provide software, they will, add features if you request them and pay for them. But their main way to make money is by supporting their customers using that software, which involves fixing bugs, providing telephone support, email support, and whatnot.
Yeah.
But in, I think, last 10, 15 years, a lot of cloud-based services have come around where it's fuzzy how open source looks like, because sometimes you're not really paying for the software, you're paying for the cloud service, that the experience they are providing to you. For example, I currently really like this software called Discourse. I keep a good track of it. I don't know if you're familiar, but it's a software to create forums. I mean, it's a forum software, and you can host your own forums with that. And the way their model works is their complete software is free. It's an open source company. They have developers all over the world, including in India. They all work remotely. And the way they make money is they provide their Discourse software as a hosted service as well. So companies or organizations that need it, they don't need to configure it themselves. They will provide the server infrastructure, any maintenance needs they want, and they're nicely profitable. They even donate to other software projects. So I would say that, I mean, always situation varies based on what product you're making, but it's possible to run a company with completely open source software, but it's not without its challenges, because there's a lot of issues that are that affect how will your software be adopted or not.
Okay. So that gives some hope to people who are who want to develop, whose dream is to start a company around free open. So the next question we have is, do you believe in force purism, that we should avoid everything that is not force? Is this practical?
Yeah, that's a pretty interesting question. I mean, back when I was naive, my first year in college, for example, I was really into FOSSCell. I kind of was like that. I would believe in, let's try avoiding all paid software. But ultimately, you have to be pragmatic if you want to, live in the world where everybody else lives too, along with you, and be able to cooperate with them, right? So I recall, like, Farsin, you had mentioned how Jitsi did not work for you all while trying to host video chats. So you have to use reliable software most of the time. And I chose to use Zoom because, again, it's not a paid software, but it works really well. They're really good at their job. So my philosophy has been even from during college time, especially, I guess, middle of college, I realized that you want to be using the best tool for the job. And sometimes you can get open source options, sometimes you don't. And you decide based on, the budget you have, the effort you want to put in. Like, for example, this operating systems wars. I mean, I was a very big Linux fanatic. I used to love using Linux everywhere. But I was okay accepting the amount of time I had to invest in, keeping my desktop running, as in uh, like installing all the software you need. So I used Arch Linux for many years. I used Kubuntu, Ubuntu, for a little bit Debian as well. Thing is that you learn a lot, and it helped me grow. But when you actually want to do real work, like right now, my main work is on doing research. That's what I get paid for. That's what makes me make progress in my program. You cannot afford to spend a lot of time on just configuring your machines and supporting that. So you have to be pragmatic at some point and decide, like, this is what is more important, and this is what what tool lets me do my job best. So right now I'm using a Mac machine, and I bought it just last year, and I've been super happy because everything just works, and I don't have to spend any time thinking about, oh, this isn't working, I need to fix it, or now I need to go find another machine. But I do have access to a Linux machine. I have a Windows. I mean, it came pre-installed on my laptop, and I dual booted it with Linux and primarily use Linux. So I have access to all things I need. And sometimes you're sort of forced to use something specifically, like, at least, I mean, I did a summer internship this past summer, so they sent me a Windows machine, and it was at Microsoft, so I had to use a Windows machine. So one as a person, you should be comfortable, working with different technologies, especially if you're working in the software field. So that's the approach I take.
Okay. Okay. Next question we have is, could you tell us a bit about your campus life? Things you enjoy, things that still gives you a nostalgic feeling about an NITC.
Yeah, I think that takes me back to 2009, 10, when I had just started. By the way, if I want to just say that I know we muted everyone, but if people have questions, they can raise their hands, follow-up questions on what I'm saying. Or I think the chat is open as well, so you can type something there, and we can, oh, somebody already typed something there. That's not specific enough, so I don't know how to respond to that. So yeah, please, I want this session to be more interactive, so please try to raise your hand. I think that will be easiest, and we can unmute you so you can speak up. So yeah, going back to college, yeah, I think I had a pretty good time. I mean, I do look back with fond memories of college. I learned a lot, like as in. So before that, I was in, I had spent almost all of my life in Ghaziabad, like growing up, and had not really traveled a lot. So coming to NIT Calicut was kind of a great experience because there were people from sort of everywhere in India, and also some people who were from other countries. So it was like a huge, like your mind opens up, like there are other kind of people in the world, and you get to make friends with all of them and learn from them and see their cultures as well, because a lot of these cultures intermix and celebrate their festivals. Like I remember the first Onam we had, and Christmas. I never celebrated Christmas, for example, back growing up. So things like that. So so there was that aspect. There was called hostel life. Oh, and the A hostel. So I wanted to share a story about that. But before that, you need to tell me, do first years get internet access in the A hostel anymore or not?
No, first years don't have internet access.
They still do not in 2020? Wow, that's a terrible situation.
I have to confirm with the recent current second years, but before that they did not have.
Right. So Yeah, I think that's just bad because college is a place where I mean you're supposed to have a lot of freedom, and um, internet access is just such a trivial thing that everybody should have it. So the story I was going to was I was very frustrated with this, that I didn't have internet access in first year, right? So one of the things I got involved in was with the back then department head's help, uh, Vineet Paledi sir, I got involved in the redesign of the department website. So that gave me actually a good access to internet because I was given written permission to go to the software systems lab at nights, even in my first year, which was kind of a big deal because I recall first years were not being allowed for that. I mean, I don't know the reasons for ragging and stuff.
Exactly. It's still the case.
Yeah, so, well, yeah, I was not okay with that. Um, so I did the best I could to, get a LAN access to our hostel as well. And we actually succeeded. I think by Jan or Feb, me and a couple of friends, we had gotten all the permissions. We collected LAN cables, we collected money from the people in the hostel, bought LAN cables, all the equipment we needed, and actually set up the LAN in the hostel. So I think that we were still restricted, like we were only given internet for maybe 2 or 3 hours at night from the CNC, but it was much, much better than nothing, right? So that was like, I mean, I think that was a pretty good experience in trying to kind of come over the limitations the system imposes on you, like the university or the institution, right? And I think, yeah, I mean, college is a time that people should think about these things and try to do something about them instead of just accepting it as, this is what it is and we have to live with it. So I was kind of a rebel in that sense. So there's a clarification here. We did have internet actually, but it is in a designated room in my first year, but not sure if they got Wi-Fi now. Oh, and Wi-Fi was another thing. Yeah, I think none of the campus had Wi-Fi back then. So we were trying to push for that. I think the department, at least department building, got the Wi-Fi, or students were not given access near the end of my final year. But yeah, these things I think help empower a lot of people, so they should be made available, and students should demand for that. That was that. Another really good experience I had was working on FOSS Meet in my first year. I think since I was already taking some interest in web development, I helped develop the first FOSS Meet website, and I have really fond memories of collaborating with another friend, Pranav Ashok, who was, I think he was also involved with the website. So we both would, go out to SSL at late at night and work on the website together. It was quite fun. Yeah, rest, I mean, I guess if there are first years on the audience, they probably haven't seen the campus, but most of you know how the campus is. And give me a second, I need to turn off this heat that will be loud. Okay. All right.
Yeah. Could you tell us a bit about your experience right after college? When you got your placement process and your experience right after getting hired?
Sure. Yeah, I guess that's a good tangent from the campus life because, how the process in the college is that there's that training and placement department, they bring in companies and you write tests and stuff, right? So yeah, I did not unfortunately do any internship during the summers. And in retrospect, I think that was a bad idea. It's always good to use your summers productively. And I've seen that like in US universities, even right after first year, people tend to do internships because that gives you very early industry experience. And it helps you get a job offer too later. So that's secondary, but yeah, it's useful. But yeah, I did not have that. But yeah, so I got hired through campus placement itself at Oracle. Oh, interestingly, I also got to got to actually interview with Facebook at the time, which was a kind of a fun and weird thing to happen to me because was not very good at coding back then. But what I knew was, so in the department, they were mostly teaching just C. And C is good, but it takes a lot of time to write simple code. So I had picked up Python on my own, through various Python workshops that we had been conducting through FOSSCell and CSEA. But I recall the placement test for Facebook was like, they had asked like 3 different departments to participate, and they just had to do an online test on HackerRank or something. So it was pretty funny that only 2 people got in that first place, Facebook's first round. And that was my friend Shamil, who actually did the hard work of implementing a hash table in C within that 1 hour time period. And I took a huge shortcut by choosing the language Python and using its dictionary data structure to do what they were asking us to do. So in a way, I was not very good of a coder, but since I was using the right tool, it helped me. It helped me go through that process. And yeah, I recall like I was probably being very smug that I had finished the stuff in 20 minutes instead of the amount of time they had given us, and was leaving. And was also, yeah, my solution was accepted. But in retrospect, it was not the best thing. Because yeah, I didn't do very well in the second round after that. Because yeah, as I said, I was not very good at coding. So Oracle's process was pretty standard. Like they, do their regular, I guess, what are they called, standardized tests, which I hated because it did not make any sense in doing software engineering jobs.
Yes.
But since there are so many students participating, they have to do some sort of filtering apart from GPAs. So we went through that. There was the regular process, and then they gave the job offer. But I at the time, so this was 4th year, right? So early in the process, probably September. I think they had the option that you could apply for 1 more company if you wanted, but I decided to not do that because I had so many other things going on in my 4th year that I wanted to just take a job offer and focus on those instead of spending a lot of time interviewing. So I was the secretary for CSEA, and I really wanted to do a lot of work with them. Then I had my final year project to work on, and there was something else going on. I forget. But oh yeah, GRE, right. I was planning to apply for higher studies, so I had to write my GRE and TOEFL exams. So all of that was just taking over my life, and I basically decided to keep the first job offer I got, and not even try with other companies. Again, in retrospect, it's not the best way to go about your life because your first job is it sticks with you the whole life in some sense, because that's where you learn the most basic skills in the industry. It's on your CV everywhere you go afterwards. So yeah, you should strive for the best place you can go work for your first job. But overall, I think my first year at Oracle was pretty good in terms of experience that I got. How whole big industry works and how they maintain the quality of software they do. And when I was finally again applying for higher studies in my, so I, I wrote GRE and TOEFL the first year, but I didn't really go in, in the final year. So I didn't go straight after. I think I did not actually apply to universities at the time because my scores were not that great. So I applied again in my first year at Oracle, and I realized that during that time, given the exposure I got in the job, I had a better idea of what I wanted to do in my master's or PhD later. So I think even though you may want to go for higher studies, probably, I don't know, whenever you want to do that, having some experience in industry helps a lot focus your interests. Like you get to see real world problems. And personally, I think in my research area, what I'm doing right now, it has a lot of motivation because of what I saw at Oracle and how software fails, like what kind of bugs creep in without software engineers realizing, even though they have spent so much time and effort and infrastructure set up to make sure things don't break, but they still break. So I found the motivation that the right way to approach this problem is by designing better programming languages. So you can formally guarantee that bugs cannot happen. And that's what I do now.
This is Vineet Paleri's favorite topic, actually.
Sorry?
This is Vineet Paleri's favorite topic.
I mean, indeed, Vineet Paleri sir has been a huge influence in my life, to be honest. I mean, I worked with him from my first year since, he was advising me on the department website. He has written all of my recommendation letters to wherever I have applied. And I mean, we still talk. I mean, just like, I think a month ago, I was talking with him over email, and we also had a video chat. So I think definitely, Vineet sir, I still quote him on my slides, actually, when I give my research talks. I write that, I don't know if you all have heard it, but Vineet sir says these things that civil engineering as a professional discipline, I mean, our civil engineer guarantees like, that the bridge will not collapse or sort of how much strength it can take. But software in software industry, we do not do that. So in computing, we have come a long way in terms of it being a science, but as an engineering discipline, we have a long way to go. So yeah, that's kind of my driving agenda right now in my research.
We have a question. Did
yeah.
FB come? Was it an on-campus process or was it an external process?
Yeah, indeed. They did come to campus that year. It was 2012.
Okay. So you said that you tried GRE and TOEFL after once again. So could you how could you find time while working, and you had a day job also? Were you able to properly find time to prepare?
Yeah, that's a good question. Yeah, I mean, you have to. I mean, obviously, once you are out of college, so college sort of enforces a structure on your time because you have certain classes to take, so they fix your schedule for the mornings, and then there are deadlines to do your assignments and midterms or exams, right? But once you go out there in the real world, you sort of have to take control of your time on your own. And I think the way that works for most people is sort of put boundaries on how much time are you going to spend working on your full-time job, how much you're going to give to your family or to your social life or to entertainment, things like that. So yeah, I think from the beginning, I recall I made some mistakes like early in my job. I think I was spending a lot of time at work, sometimes even up to 10 p.m. But once these, I think GRE TOEFL deadlines came closer, I realized that I had to limit that. And most people do that. Like the ideal way to go about it is like, let's say they say it's a 9 to 5 job, keep it to 9 to 5. If you are focused, not checking social media during that time, you're actually getting work done. Most of these full-time jobs are doable within that time frame if you're not too distracted. So if you do that, then you kind of have the rest of the day for you and you can do whatever you want. So I don't manage to completely, implement that even right now in my life. And it's been like 10 years, not 10 years, but yeah, since college, it's been 7-8 years. But that's what I try to aim for. And that gives you a lot of control. And yeah, now if after you're free after 5, you do have a lot of time to study, to go out there and write your exams or pursue your personal hobbies. Like I used to read a lot of books. So, I mean, yeah, I did that during, I think especially my reading grew a lot during that time in Bangalore when I was working. I didn't read a lot growing up just because, yeah, my family doesn't read much and my school did not enforce that on me. In college, I picked a little bit, but there was not a lot of time and there were so many other interesting things to do. But I think at my full-time job, I got this good habit and that has stuck with me. The general point is you can design your life the way you want once you are able to take control of your time.
Okay, we have a question. Could you point out a few things that you did in college and industry that you think helped you get an admit at the University of Chicago?
I think I would say by the time I was applying to University of Chicago, uh, things that mattered most were what I was doing at that time. And I was already at Brown University by the time, and I had done a research internship after my first year. So I was applying in my beginning of my second year, right? So that was 2016. So those things matter a lot more than what you've done in your past life. Of course, you have to provide your transcripts, you have to say what you did in the industry. And I framed them in the way that they inspired my research. Like I saw these kind of problems in the industry, and I think in my PhD, I want to tackle these problems. So you have to write a statement of purpose, right? So you have to put your experience as a motivation to what you want to do further in your PhD. So that definitely helped, but I think during these PhD admissions, what matters a lot more is the recommendations you're getting from people who are writing your recommendations. So I had one from Vineet sir. I got one from my mentor at my research internship at HP Labs, and I think I had one from one of my professors at Brown University as well. So once you're at that stage, people sort of know each other in academia. Like they know that this person works in this field, and if they have written a recommendation for a student, then they can trust their words. So if people are curious about how to go about applying for schools, I maintain a web page, and I can share a link right away, because that's a common question I get all the time, and there are a lot of online resources to learn about it. So I've posted it in the chat. You can look at it. It's very detailed. Some are master specific things, some are PhD specific things, some are very general. But yeah, in general, I think primarily my experience, college transcripts, recommendations, a combination of all of these things help you get into a grad school.
The transcripts means grade card, right?
Yeah, they're in the US, I think they're called transcripts. Even in NIT Calicut, I believe, when you request it officially, once your degree is complete, they give you a transcript of all of your scores from first semester up to 8th. Yeah, but yeah, it's kind of a scorecard.
Okay, so GPA does play a really good role in getting admitted to foreign universities, right?
It varies, to be honest. I know a lot of even NIT Calicut alumni who, not a lot of, okay, maybe a couple, I know very few who actually really went to academia, are doing their PhDs and stuff, because a lot of people just go for jobs, I mean, after a master's. But I've seen if you're actually good, GPAs is just one part of your overall picture. I would say the biggest role that is played is by the recommendations that are coming with your application. And the general advice I will give you is, if you're approaching your professors or your, if you did internship, maybe your mentors at the internship, when you approach them, ask them if they can write a strong recommendation for you. That strong word is important because sometimes people just write recommendations that don't say a lot about you.
Okay.
So, I mean, this obviously involves that you have worked with them, actually impressed them, and they found that you have a good work ethic. You can actually do what kind of problems that you work with them, or in case of courses, like obviously it helps when you have performed very well in classes as well. I think some faculty give you recommendations if you have A's or S grade, if it is still called S. So all of that, they will include in their recommendation, but you have to ask them, will you be comfortable writing a strong recommendation? You also don't want to put them in a situation where you're like, if they're not comfortable, probably then you should talk to someone else who will be more comfortable. Because a generic recommendation is not very helpful. You want people who are recommending you really like strongly believing in you and pushing you in the what they write. And again, there is a link in the chat that I posted about how to write recommendations. You can actually even share this with your recommenders.
Okay, so you have recommenders, a recommendation from NIT Calicut also helps.
Yeah, totally. I mean, as I said, my Vineet sir's recommendation has gone with my PhD application, with my master's application, maybe, yeah,
Okay.
primarily these two. Even some smaller things I had applied earlier, but that was closer to when I was in college. And for my master's, I think all three recommendations I had from college.
Okay.
Because I couldn't, at Oracle, I think the environment was not welcoming enough that I didn't feel comfortable asking my manager to write me a recommendation, even though I had been doing very well in the job. So I never approached him. So all of my recommendations came from, and I didn't do any internships before. So all of the recommendations were from college professors.
Okay, that's interesting. So how did you choose your area that you want to focus on when going for master's and PhD?
Yeah, that's a good point, and I think it took me a lot of time to narrow it down. Overall, I think while at college, as I mentioned, I was initially involved with web development, so I really liked that a lot. But I didn't see any research opportunities in that, or not the interesting stuff. So the second interest I gained was in systems in general, like working on operating systems, networks, and stuff. So I did two projects. Like back then, they allowed you to do a mini project in your third year.
Yeah.
I don't know how the requirements are now. So that was in operating systems where, I was trying to just pick up stuff, learn stuff. And then finally, it was on compilers where I worked with Vineet sir. And that's also, a systems thing in some sense. So the idea is that if you're interested in a particular research area, or if you want to see whether you will be interested, do a project in it. And then you will get to see all the gory details and realize that whether you actually like it or not. And mini projects or one semester projects, even a year-long project, it's not such a big deal, because if you're still in college, you are pretty open to doing experimentation and figuring out things. I mean, it obviously helps. Like if you nail it down in the first try, you have better things to write about it in your statement of purpose and motivate your research when you actually apply to schools. But there was that, and then I took an industry job. So Oracle's think they help you. They kind of have a process in which they help you pick what team you will be matched with. So I picked the team which was closest to systems in the sense I was interested in. So that's a database company. I was overall in a database team, but I was working on a layer called virtual operating system, which was very close to operating systems in some sense. So that's where I spent 2 years of my time there and learned all the problems I was saying that helped motivate my research. At Brown, during my master's, it was not a research-focused program. It was mostly a coursework, but you had the option to do research, and I did that. But again, once I was there, I was really trying to gain as much as I could in terms of depth in systems. So their course qualities are like superb. Like one of the classes that I did not officially take, but I sat in because the lectures were so good, was a class meant for first and second years in the program. And start in C, this is called systems programming. And I realized that the amount of stuff they were teaching and students were doing within a single semester was more than all of C programming I had done in my 4 years of college and in my industry job. It was that much work. Super, intense, but it also made you so much better. So the difference in quality sometimes you see in what you are learning at, schools in India, especially at NIT Calicut. I should probably speak only for that because I haven't been to any other school. Can be really vast. So like, I think somebody was mentioning earlier that you're doing more work now that there are no final exams. In US universities, that's a common thing. Like most programming courses involve a lot of project work. You're writing code almost, not all, every week, but sometimes almost every day. And that's actually very important if you actually want to gain really good skills. And how I was saying I was not good at programming back in college, the reason is that most of my courses did not require me doing a lot of programming. Or they did, but somehow I tended to push them to the very end and compress them and finish them soon. So that's not a good approach. I think spacing it out, like maybe they realize that actually final exams are not that important. Doing actual assignments is, it's actually the right way to do it. And I wish our uh, college experience was more aligned with that, because it helps you reinforce concepts so much better in your brains. You cannot like suddenly push things in your brain right before the exam. It works for the short period, but it doesn't stick in the long-term memory. So it's important to do that. Yeah, going back to that, so I did these systems courses. I did an operating systems class in my second semester at Brown, and that's the toughest class I've ever attended. Its projects were super intense. And I think I didn't do the final project. There was like a choice between taking the regular credit and the advanced credit. So I didn't do the advanced credit because it was too tough. But during that time, again, that was still in C. I was finding and understanding the limitations of C and getting more and more frustrated. Then I did a research internship, which was also, it was C++, but still it was not close to where I found satisfaction. But during that summer, while I was doing this internship, I also started picking this language called Rust. And I saw how language abstractions help you avoid bugs. Like Rust is like a super amazing language where most of the memory safety bugs you encounter in language like C++, the Rust compiler just won't let you do them. So that really, really motivated me that this is where I need to focus on to actually sort of do real world impact in the way people program. And so programming languages as an area. So there was that, and also just because I was in a research industrial lab, it was at Hewlett Packard in Palo Alto, California. In that summer, I was surrounded by people who were doing their PhDs or the full-time research scientists there who had PhDs. So that gave me a lot of insight on, how it's being like in that kind of environment where everybody around you is an expert in their own fields. You can always just, go talk to someone and really, quickly get your answers. So I think it gave me a real world perspective on how doing a PhD would be like, talking to all those people. I obviously also discuss with them, that I'm planning to apply for a PhD, whether I should or not. So I think that summer basically changed my mind. Like before going to that internship, I was thinking like, oh, I'm not gonna apply for a PhD. I'm just gonna come back and do a job, after finishing my master's. But by the end of it, I was like really motivated to first I was able to nail down the area I wanted to work in, and also motivated in terms of what it will be like. So that helped a lot.
So, do you find the workload in a job or the PhD more hectic, more manageable?
Yeah, that can vary. I think right now I would say my compared to all the industrial jobs I've worked at, PhD is more hectic for sure. But I also know some people, like I was talking about this 9 to 5 thing, right? Some people who during their PhD are able to do that. So it comes down to a lot of sort of personal discipline and, experience and, habits you develop over time to control all of these things. But I also recall back when my first year at Oracle, I was putting in a lot of hours at work. So I could say it was hectic, but it was probably not as intense as it is right now. Intense in terms of how much mental effort it takes. So yeah, it can vary. And sometimes people in the industry are putting in a lot of work too. I mean, the Microsoft internship I did, I was amazed that like the software engineers there were like super amazing. They were doing very hard things sometimes and putting in a lot of work. So it depends on what you're doing, how motivated you are to do it. Because one way to go about it is you do the minimal and just keep floating in your job. One is that you actually want to improve, so you keep trying to do more and more work, impress your peers or your bosses, and go high up in the hierarchy. And sometimes you end up doing research at your job itself because the level of contributions you're doing can change the way people do things. So you can, have a bigger impact that way. Obviously, that's harder. I mean, and that happens once you have grown a lot in your job, the third level. But yeah, there are various ways you can go about doing it. And sometimes you have other priorities in your life. I don't know, you're getting married, or you have, I don't know, you have to apply for a GRE. So you have to limit how much time you will put in your job, right, to do the next thing. So that can vary. But going into a PhD, definitely generally expect it to be much harder and hectic than a comfortable engineering job, and for much less pay.
Okay, I was going to ask that.
Yeah.
So, like, because the cost of living is very high in US, the stipend you receive, is it manageable?
Oh, no, I think that's totally manageable. So the way they give you stipends is it takes into account what the cost of living is in the particular city you are in or area you are in. So yeah, I mean, obviously you cannot live a lavish life, right? You have to live within your means. But overall, I think the stipends we are getting are more than enough to, you know, live your life and even save money. I mean, I've been able to, yeah, it's been pretty comfortable for me. And when you do an internship or something, you obviously get paid as like a full-time employee. So you can, uh, I guess, splurge on things. Like I bought a lot of headsets this past summer because pandemic happened and I also just needed them. And I also had more money because of the internship.
Okay. Could you talk about a bit about your current research field in simple terms that is understandable by BTech students?
Sure, yeah. So do you want me to talk about programming languages or about quantum computing?
The thing that how verification and how it interacts with quantum computing, why is it more relevant in quantum computing, things like that.
Yeah, so I wouldn't, so just to clarify, verification is part of what I do, but that's not the main thing I work on. It's generally programming language design, and verification is sort of on the periphery of that, and I do some of that. But to your question about how verification is important in quantum computing, so right now, I think, and one of the questions, sorry, I may be answering that question already. One question I saw was when do you think quantum computers will be available for general usage, right? So let's start with that, because that will motivate why verification is important. So one thing to know is that quantum computers are actually becoming real. It's not just a theoretical field anymore, which it was for a long time. And I've visited at least 2 labs where there are real quantum computers. So last year, Google announced their big experiment of, they called it quantum supremacy, where they demonstrated that now we have a machine which can do more and faster processing than a classical machine of the for the same problem. So, but that was sort of a demonstration. It didn't really give you much. But that justified like why people, like companies and countries even, are investing so much in quantum computing research. And I think since then, there's not a lot of progress being made. Like different companies are saying we have this many number of qubits. That is the amount of computation you can do is sort of slowly growing, but still it will probably take at least 10 years for useful quantum machines to emerge that people can think about using. And I would backtrack a little bit. I mean, when I say people, I don't really mean like you and I, because the things you can use quantum machines for are very specific. You cannot do general purpose computing with those machines. There are only a certain kinds of algorithms or applications that are suited to quantum computing. It's not, it cannot do everything. And the amount of computation power we'll have in the near future is also very limited. But that itself helps motivate why verification is important, because you have very limited resources or qubits. So if you actually want to design algorithms that you think will give you the right answer, you need a way to verify them without actually running them, because you literally cannot run those algorithms or programs that you write just because there are not enough computational bits or qubits on quantum computers available. Like in classical computing, to test something, you generally just run it and see whether it works. So it's a harder problem there. And in my own research, I kind of focus less on specific algorithms correctness, but more on the whole computational model. Like, how do you program these machines? So there are concepts like superposition, entanglement, and stuff. I know many in the audience may not be familiar with these terms, but they're not important right now for the discussion. So, but they're sort of a different way of computation and very important for designing algorithms or doing computation with quantum machines. So we want to expose programming language abstractions that let you, manipulate qubits to create superposition or to create entanglement or to do the other way and make sure that the answers you're expecting from your program are actually correct. So that's where work in programming language design to expose the right abstractions and verification of the languages themselves to make sure that programs you write in the language are going to be correct comes in. And that's what I'm trying to do. So again, my general interest in programming languages, quantum computing is sort of an application domain for that. And to be entirely honest, I had basically zero knowledge about quantum computing when I started PhD about 3 years ago. So, and it was not even in my application. My advisor who works on programming languages and compilers told me that we may work on quantum computing. We are applying for a grant. Do you want to start looking at it? This was my first month in my PhD. And I said, you know, grad school is for doing hard things. Let's figure it out. Let's see if it will be okay. And yeah, I started reading, learning, and it turned out, yeah, I liked it. It got funded, and now that's what I've been doing.
Okay. So is your stipend independent of the grant, or does it come with the grant?
It So in my case, it does come from the grant, but as a PhD student, you are given funding really by the university. And the way it works is that the grants are given to universities, and universities decide how much to, get for the students who are working on that project. So
Okay,
in
so
some sense, sorry, say that again, please.
Do universities run out of the grant money?
Yeah, usually grants are for a specific time period. So yes, they can run out. In general, your PhD advisor is responsible for, if the funding runs out for a particular grant, they might be already in the process of applying for another grant because they have to, they keep getting new students or keep graduating some students. So most of the times it's not a PhD student's problem to worry about grants. It's the advisors do it for you. But as you grow in your career in the PhD program, sometimes you can help write a grant along with the advisor if they ask you. I've seen that happen a couple of times. So. But again, that's not a concern when you're actually applying for a school.
Okay. So after PhD, what are your plans? Do you intend to work on the same area? Can you work on the same university?
That's a big, large question even in my current life. So I don't know yet.
Okay.
But my general strategy has been to keeping my options open because I've seen in my own life that my mind changes after I learn new things, like it changed during my master's program. Okay. So I recall going into the PhD program, I had told my advisor that I was 90% sure I'll go to the industry after the PhD and 10% keeping open. But last year I got the opportunity to teach a class, and I did it this year. I mean, last year was the opportunity, but I taught it this winter, that is from January to March at the University of Chicago. So that was, again, my experiment of trying to see whether this will work for me. So, I was teaching this introduction to computer programming class, computer science class, to undergraduates and who had zero to very little or zero experience in programming, and I think I enjoyed it a lot. I mean, so teaching is one part of being a professor in academia. So at least that part I realized over this 3-month experience that I actually like. So now it's more like 70-30 or 60-40 of industry versus academia. But I also realized that for academia, the number of positions that are available are much lower than industry jobs. So if any of you in the audience, or if you go into a PhD planning to go into academia, you need to be really focused and probably working much harder than anyone else in your program to get academic jobs. Not anyone else, but at least be in the top of your, you need to be at the top of your game because, all of the work that you do during a PhD sort of counts, like the number of papers you publish and the conferences that you publish at, they should be reputable conferences, and recommendations from your peers, from your advisors, from your like people you've had a visit with, like you can do an internship and stuff. All of those things matter. So definitely going to academia requires more planning, more deliberate effort. So I feel so far I've not been doing that. So I need to, if I actually really want to do that, I need to start planning for that sooner rather than later.
Okay. Okay. So this is our last question. We are almost running out of time.
Oh yeah, sure.
So, okay, how did you? What is the formal procedure to apply for Brown University and University of Chicago that you had to go through? Was it just GRE and TOEFL?
So again, if you need like all the gory details, the link I posted is helpful. But every school, obviously, since they want students to come in, they give you a complete list of things you need to do. And the primary thing among those are you will have to write an application, submit an application form that they give you by a certain deadline, and submit material along with that, like your transcripts, your people who will write recommendations for you. So you write their email IDs, their name, affiliations, and the application system sends an email to those professors or people directly, because recommendations are not supposed to be visible to the students who are applying. And they will submit it, and then you have to write a statement of purpose, like why are you wanting to do this program? What will you do during this program, as in how are you motivated for? And if you want to work with a particular professor, you write in that statement of purpose, why do you want to work with this person specifically, things like that. And GRE and TOEFL, I would say, are relatively minor parts of those applications. It's good to write them. I think TOEFL is a fixed requirement. People have to do it because you need to show English proficiency. But GRE is a more controversial thing. Like a lot of universities are phasing it out from their application process. And I would say it helped me that Brown University did not require GRE scores. I had applied to, I believe, 12 programs. No, it was 14, maybe 15. So 13 schools and 15 programs. Like I applied to some schools, 2 different programs, and I only got 2 admits back when I was for my master's. So, one cannot guess what the issues might be, but I did feel like not having a GRE requirement at Brown helped me, because my GRE score wasn't that great again. Then but if you're applying for a PhD, again, this matters even less, because there you are really thinking about like a 5-year plan in some sense. So for my PhD process, I took a little different approach. I emailed almost all of the people I wanted to work with. I discussed what they're working on right now and whether our interests align. As in, if you want to work with a person for 5 years, you have to come to an arrangement of what you will be working on and stuff. Because a lot of times in PhD programs, especially if some professors don't update their web pages that often, a lot of people are very active, but some are not. So you may not know what the person or what their research group is actually currently working on based on their past publications, because that's old work. So it's useful to actually talk with them. And I know a lot of people say that cold emailing professors is not a great idea, but I think it's somewhat underappreciated skill. First, you have to obviously write a sensible email. So most professors, even though they get thousands of emails, if you have written a sensible email to them, will actually read it. And if they find something interesting, they will even respond to you. And I'm not just saying it because I did it when I was at Brown. I do recall getting responses from professors when I was still in Bangalore working at Oracle. So it's not like just because you're in India or you're writing from a place that they do not know, they will not respond. So it's not necessarily a negative in that sense. But you have to do your own research before reaching them, like see what their group works on, see, do you actually have interest in what, you can work with them, or the projects you have done, are they anyway relatable, or do you have any other ideas based on what you see on their webpage about the kind of work they're doing? Because that's what engages them. They just don't want to get spam email from people who just want to, apply to a university. They want more dedicated people who actually can become their collaborators in their work. So PhD is like a very, it's not, you're not a real student anymore. You're also sort of a colleague to professors after at least a couple of years, because you have learned enough and you can do research on your own. So you have to think from that perspective before reaching to a professor.
Okay, so that's all the questions we have collected. If any of you have any other further questions, please post in the chat or raise your hand or unmute yourself and ask, or we'll wind up. Do you have any questions? Anyone? Okay, fine. Thank you, Kartik. Thank you so much for interacting with us. It has been really helpful for us. It has been like a very good amount of information for guiding us to career and education. Thank you so much for coming, and thank you everyone for attending. So I think let's wind up. Thank you. Bye.
Yeah, thank you for seeing Muhammad and Edwin and everyone else. And I enjoyed this a lot.
Okay.
Bye now.
Thank you. Bye. Stop recording.